Well, thank you. This particular presentation is about ponds, since we all have a common interest regarding water. I'm going to say very little about fish, but if you get me started, that will change. It was prepared in part with Joshua Faulkner, the ag engineer for Extension, who's just down the hall from me. And so let's go ahead and get started and see what we come up with. The typical West Virginia farm pond averages about half an acre. This particular pond is out on the animal science farm. If you drive up the hill, it's on the left. And this is what it looks like in the summertime. It may contain about 2 acre-feet of water. It was built to water livestock. There are other benefits as well, though, whether it's capturing sediments, adding value to the property for recreation, wildlife benefits. And normally these ponds are stocked with bass and bluegill. And normally it has a weed problem. And very often that's what people call me about. So if you have a weed problem in your when I say an aquatic weed problem, I handle those kind of questions too. All right. Now the design, and there's going to be a fair discussion about design of a pond in this particular talk. The standard is to go to NRCS, and NRCS has a very long history with building ponds with perhaps less emphasis now than they used to. And they have a marvelous booklet, and this is a figure that came out of that booklet that shows a typical embankment and reservoir. It certainly is not to scale. We all know that things look a little different when you get out there. But you have a normal pool, you have an outlet for the water coming out the drain there, you have an overflow, let's see, an auxiliary spillway, so if there is a real slug of water that comes through, it has a way to go around so that it doesn't do any damage to the dam. There is a very carefully constructed so that there's a good seal on the bottom here with a core trench. But there's something in here that to me is missing. And I've made this point a number of times, and I hope someday they change their drawing. What would you think might be missing in this particular design?
Construction drain?
Construction drain. Are you talking about a drain that comes through the bottom here?
Yeah.
Yes. Most ponds in this state have been built to remain full. They're not built to be drained. And if you have to ever renovate a pond, you will curse that particular decision. If you have other problems with the pond, like you want to work with the water level, anyway, so we'll talk about perhaps some other designs. So normally these ponds are built to water livestock. And I'm thankful that Ed Rayburn was kind enough to encourage me to be on the program here today. These types of designs are well established and they're marvelous. It seems to me I found the one at the animal science farm is currently not functioning. It's not actually providing water in a trough down below there. And I think that perhaps the pond itself needs to be renovated. But this is a marvelous tool. The designs are well known, and it's a fine example. And of course, if you look at the water need that livestock have, this is again out of that particular manual, and they show how many gallons per head per day. Well, you're really not talking about that many gallons. And 2 acre-feet of water in a half-acre pond is a gracious plenty for all of these purposes, given the volume of livestock that most farmers have. And of course, most of the ponds are watershed ponds that are capturing that surface runoff, but the water level is intended to remain the same year-round. Joshua and I were kind of asking ourselves, how much water do we let go? And I don't have the answer to this, but the next question would be, and what is the value of that water were we to use it? So we went through a mental exercise. And we just chose a particular example. And I'm going to go through several slides here that gets to a bottom line. Obviously, you can have a drought year, you can have watershed characteristics, whether it's wooded or whether it's pasture or whether it's something else, whether there's seepage, and so forth. So we went through a particular routine here. Come on now. All right, we assumed 50 acres as an area. So we're talking at this point in time how much water comes off a watershed of 50 acres. We assumed that it was located in central or western West Virginia, given the soil types and so forth. We assumed an average climate year. We assumed that there was a pond in that 50-acre watershed that had 2 acres of surface area. We assumed a typical seepage of 2 inches per month. And we assumed, I'm not sure exactly what Joshua means by this, retain a permanent pool 20% of overall volume. So the basic idea is to take an average situation with about 50 acres, and we took some of these type numbers, general numbers. It's not like we have a particular farm and we have data off that farm. We're saying, okay, off of this particular chart in this area, 2.5 acres per acre foot. This is a guide for estimating approximate acres of drainage area required for each acre foot of storage in an embankment and excavated pond. Okay, so this was a source of information that Joshua went to get it. We assumed woods, we assumed good coverage, and that it would be protected from we assumed soils with a slow infiltration rate, and with these assumptions, a 2-inch rain would yield about 1/4 of an inch runoff, or about 1 acre foot of water. So in a 50-acre watershed, a 2-inch rain yields 1 acre foot of water runoff. What do you suppose a 4-inch rain would do? Twice that?
3 times.
According to Joshua's calculations here and so forth, because you don't have that water being, going down in the ground the same way, more of it's going to run off. And he estimated about 5.5 acre feet. And 1 acre foot of water is about 325,000 gallons of water. I think in terms of acre feet when I think of ponds. I think in terms bigger than a 1/2 acre very often. Let's see. Okay. So these were some of the other numbers that Joshua came up with for the 50-acre. Runoff of 20 acre feet, rainfall of 2.7 acre feet, evaporation 3.6 acre feet, seepage 1.3, and a permanent pool volume of 4 acre feet. After losses, he estimated that there was 13.8 acre feet available for consumptive use. So we're letting that go every year on 50 acres of water. That's a lot of water to me. What could you do if you had that water? Do you think in terms of using that water for something? Anybody here, really? I want to know if there's something on your mind. What? Fish farm, irrigate? I mean, you got to go with, yeah. Generate electricity? If you're using it for human consumption, you're going to have to do something to it, obviously. If you're using it for more livestock or whatever. So that's kind of, yeah. Say again? I didn't understand, I'm sorry. Dry hydrant, yes, absolutely. So when I look at the traditional design of a pond, what I see is something that's especially good at watering livestock. I mean, that's originally the way it was reason it was built. It does add value to the property, and these days we have homeowners that want to have a pond near their property. Perhaps they'll use it for a dry hydrant, and that'll lower your insurance rates a tad. But they're not thinking about watering livestock. They're thinking about recreation. They're thinking about just a nice vista. but recreation is obviously important to them, and fishing and so forth. Wildlife gets benefit from these things, and it does capture sediment and nutrients, and I'm sure that was an important goal for the original pond projects that NRCS was involved with more commonly in years past. And there's your dry fire hydrant. So absolutely. It's not so good for some other things. There usually isn't enough water there to irrigate. You have a half-acre pond. You can water your livestock, but for livestock, if you're doing 10 gallons per head per day, it's a relatively small volume. If you're irrigating an orchard, for instance, I don't know how many inches of water you have to put on, but you can use that half-acre pond, that 2 acre feed up fairly quickly for irrigation. For field and orchard spraying, you might be able to use it a good bit. One of the things that you normally want for field and orchard spraying, a nice clean water supply that doesn't have debris and so forth in it, doesn't have aquatic plants that'll help clog things, and anyway, aquatic farming, that's where I'm coming from, okay? We can use this water to grow things, whether it's for our personal use or perhaps to create a profit opportunity. I'm always interested in microhydro, but I can't say I have ever seen anyone doing it successfully. And I always use that as a litmus test. If there's an idea out there that's been around a while, and I can't find anyone who's doing it and making it work, whether it's for personal gain or for personal profit, I'm usually suspicious of it. But I'm still interested in how can we capture the energy off this. And then if you have, these days, you know, we're having with this, well, the strange weather that we have, sometimes we have rather severe downpours here in West Virginia, and I got to tell you, the reason I'm in West Virginia is because I got flooded out of Georgia. All my fish swam away. Now, you think that you know, when you have a flood with beef cattle or something, the animals drown. No, I saw goldfish going along the yellow stripe of the highway, just swimming away. But I look at these local downpours and the amount of flooding in this lock area that we've got down here. One of these days, I can't help but believe that all the cars in that, well, I don't need to go into all this. But capturing and storing water for other uses is something I think that we ought to consider more carefully in the future. And then learning how to distribute that water for the highest possible value. What would be some high value uses of the water? What would be, I mean, if you irrigate an area you might graze with cattle, the return on that, Ed Rayburn, he tells me, Ken, that's neat, but it doesn't, you know, I really can't justify the investment in the equipment and so forth. So what has higher value? Vegetables. How about an acre of sweet corn? Okay. Some high tunnels are hot these days, but you know, high tunnels have to have a water source with them too. You've got
Another high value would be the protection of flood. When
Okay.
you have a rain event sometimes in certain areas, that's why we have most in West Virginia.
Okay.
The runoff protection for flooding.
Well, we don't build our ponds really to accomplish that, do we?
Not the farm ponds.
Not the farm ponds,
That's
right.
standard, but there's
Right. Okay. So I'm going to show you a few other drain systems here. These are things I've run into through the years. I don't remember exactly where this particular figure came from. You may have seen it before, but in this case you have a handle that goes down to a little valve, like a shear type valve, and then you have a riser here, and there's I really like this. They put a wider pipe over the top of that so that you're doing what I call deep water release. That is, the water is being released from fairly deep in the pond, and it goes out. And of course, this is just normal drain, so the water level is actually set by that riser. And another thing about this feature is that the drain pipe is actually up off the bottom of the bottom of the pond. So if you tried to drain this pond completely, you'd end up with whatever depth of water that is there under, which is okay if you have to. Anyway, I'd rather have it all the way to the bottom. Here's Pond Dam Piping, a place out of Georgia. And they also sell these siphons. I think I have something on that, but this is very similar to the other one. This is all PVC material though, and they have a trash rack, and they don't have the deep water release on this. You may have run into AgriDrain. AgriDrain has a very interesting and I think a very nice set of products. And in this particular case, they have these boards that slide into a groove. And here's your water level set by those boards in that tower. And once again, you can get deep water release off the bottom of this pond. Of course, all of these things that are put in the pond have anti-seep collars. And of course, when you're making a pond like this, it adds cost. Putting this type of system in adds cost. It's something that you really benefit from if you ever have to work with that pond in the future. But in installation, sometimes you short these types of costs. So if you have to ever drain a pond, and these are some of the reasons, you have to repair a pond. Sometimes ponds will get full of silt. You know, over a period of time, they'll add up, or they'll get a whole lot more mud on the bottom of them, and you may have a need to renovate it. There are some types of weeds where if you have a winter drawdown, you can kill the aquatic weeds around the edge. And that would be another reason to have the ability to control the water level. When these sediments build up in these ponds, they'll have a lot of organic matter in it. And if that is exposed to the sun, that will bake. You've seen mud bake down over time. It gets thinner and thinner and thinner. It cracks. And you can oxidize these sediments. It's actually very good. It's healthy for an old pond to be able to dry down, and it's a way to, actually you can make a lot of these, the nutrients more available than when you fill the pond back up again. If you ever have to recover fish, it's handy to have the drain. And imagine if you could not empty a pond, you couldn't be sure that if you're going to grow a crop of fish, you basically have to finish one crop, get all the animals out, and then very often you'll poison it so that there are no animals left, even in the drain pipe or even in the footprints or the holes that are in the bottom there. If you end up starting and you don't do that with the next crop, let's say you're going to grow bait fish, and you end up having some rock bass or something that escape, or some largemouth bass that escape, they're going to eat up all your bait fish, and your bait fish crop is just going to be polluted with fish you don't want. And the other thing, that none of these particular designs are taking advantage of gravity. If you have to distribute that water, isn't it nice to have good old gravity flow working on your side? Okay, so I'm going to throw out the concept of a multi-use pond, and I will not claim that I have one. I wish I did. I'd like to put one on the Reedsville farm. I have a location picked out. But this particular concept is where you're intending to capture the surface water and manage it for a variety of benefits that really can be set by you. You can decide what enterprises you want. If you applied this, you would end up with larger impoundments, watershed ponds, and some way of a different design on the drain system. Now, here's my first attempt at a drawing. Okay. On the top, you have temporary pools, so you're going to have an emergency spillway. That's still there. You're going to have an upper pool, which is is very often there'll be a pipe through the top there that'll set, and so when you get a little bit of rain, it'll seep out the top or flow through the top there. You might define then and have a lower pool, or you say, look, I'm gonna use this middle amount here. This area is this water is being stored for use. So you set aside in your mind, I'm going to take the top 4 foot, or I'm going to take the top 3 foot, or I'm going to take the top 6 foot, whatever it is. And then you have a drain structure of some sort that will allow you to do that. Now, I have in here something with a swivel. How many of you are familiar with a swivel used in a drain? Okay, not many. They're far more common in Arkansas. I had several years where I worked in Arkansas, and so I've become accustomed to them. It simply allows you to turn that pipe up or down. And in Arkansas, they actually put them on the outside. But here in West Virginia, because of ice and so forth, if you had a PVC one or even a steel one and it froze in there, that would be kind of bad news. So I'm putting the swivel on the inside, and I've also got on the top here. This is like a deep water release type of thing, but I know this needs more work. This is just a conceptual thing here, and all of the other things go with anti-seep collars and all of the other types of considerations. But I like to have the drain pipe set low enough that I can drain the pond completely. And I'll show you some more why in a minute. So the basic difference is in the drain structure. Drain the pond completely and keep it empty so it can dry. Capacity to store water and use it as needed, and discharge from the pond taking advantage of head pressure or gravity. To me, those are the components of a multiple use pond. And so here's a couple of ideas. You could vary the size of the storage area. Again, you can set aside in your mind whether you're going to take the top 2 feet or the top 10 feet of water. And you can have a variety. I have what I call consumptive uses and then non-consumptive uses. And think of this, if you take and you have first a non-consumptive use followed by a consumptive use. So you end up using the water twice. So traditionally we're talking about watering livestock. Let's keep doing that. Maybe you want to have an acre of sweet corn. Maybe you want to grow peppers. Maybe you want to grow some kind of higher value vegetable crop that you might sell locally. Maybe you'll have a high tunnel. Maybe you'll have both. These days, some people are building ponds to harvest water so that they can use it to frack. I'm calling that the fill and tote. And it's not as though this is a reservoir that's used at the well site. This is simply a place where you're capturing the water, and that water then is being taken somewhere else where it is used. So this is simply harvesting the water, and you use it as actually there are a number of ponds that have been built by the energy companies for this purpose. I like this one, of course, whether you're holding fish or you're growing fish for market. But I don't know if there's a possibility for microhydro, and that's why there's a question mark there. So these are some of the ideas. How much water does it take to grow an acre of sweet corn? I think you're talking about maybe three applications of 1 inch. How much is 1 acre foot of water? If you have 1 acre foot of water over a 30-day period will deliver 7.5 gallons a minute. If you have 1 foot of storage, 1 inch per application, 12 applications over a 1 acre area. That's 1 acre pond, half acre pond, 1 foot of storage, 3 inches per application, 2 applications over a 1 acre area. These are just different scenarios that you could go through. I also look at maybe having some levee ponds below that and having maybe a crop of catfish fingerlings in there, maybe some bluegill or hybrid bluegill in something like that. There is new technology that comes around, and Joshua gave this to me, a supplier of grassland and forage irrigation systems. This is out of New Zealand. And this is a little different type system, and perhaps at some point new technology will make it that we can make better use of our water. Another management strategy, well, large storage capacity, leaving the valve open. All right, I'm going to go through here. This is where I like the flooding type thing. Imagine if we had these things spread over a watershed, and let's say they were dams large enough that you're going to use the top, say, 6 foot of water, or the top 4 foot of water. If you had them in series, what would be the result? Let's say this one is at the head of the watershed, this one is another, half mile below it, and this one is maybe another 500 feet below that. Or maybe there's this even more on the watershed. What would tend to happen is that, and if you ended up where the water was then distributed by essentially what comes out of the drain rather than what goes around the spillway, it would be like a big sponge. Certainly it won't be as dramatic as that, but it could have an effect of spreading out this flow over a much longer period of time, or at least a portion of the flow.
What it does is it takes the lot of water.
Okay.
Fast, at number 1 pond, down.
Okay. But it doesn't have the effect if all of the ponds are full and all of it just happens, all of it goes around the spillway, it spreads it out a little bit, at least the difference in your temporary pool. But if you had these things designed so they were intended to capture water, and you considered a water budget for distributing that water over a particular time, we could have a greater impact than we do with our current ponds. I like swivels. There's a set of swivels down, and I forgot to bring one with me. This is an example of something that's made out of PVC, a guy in Arkansas. And this is the swivel right here. There's 2 particular designs shown here. This is the simplest design. So this is swiveling, toward you or away from you. And the same is true of this one. This is where the drain's coming through the dam, but it has an elbow on the end so that that particular swivel would swivel so that the pipe would swivel out toward the deep water, or the deepest part of the pond, or the center of the pond. And this other one on the other side here doesn't. But anyway, these are the types of systems that they use in Arkansas. Here's an example of a little drawing where you have your drain pipe through, and then in this case it would swivel left or right. Let's see. And I always like to take and put a deep water release situation on. Tom Baisden. Tom, are you here? Tom put one of these in his pond. He's got a pond just below his house, and he's got one in. You can also put the swivel on the outside, and this is what we did in Arkansas. And we ended up having a winch. One of the problems we had to tie the handles on these winches because they had cattle. Those cattle would go up and rub against that, and they trip that winch, and the pipe goes down, and when you come back in the morning, the water's dropped about 3-4 feet. Fortunately, the fish don't tend to go through at that point. And this is a design. I actually have a drawing on this if anyone wants it. If you make them out of steel, this is what we were doing in Arkansas. I was there. We made these swivels in Georgia. We actually bought one, we copied it, and the farm I manage, we had to build it before we managed it. Here's an example at Rama Memorial Pond. I have one of these. It's a very shallow pond, and actually putting the swivel on the inside in a shallow pond is a lot easier than a deeper pond. But at Rama Memorial Farm, the beef testing, beef cattle testing. I'm sure you all have been there for that purpose or heard of it anyway. There is a fish house. And if you happen to go there, please do stop by. I have a fellow named Matt Farrell. But what we have is we capture the water. It goes into the fish house. And then it goes into the pond. But we've also got a greenhouse and a high tunnel where we're doing some aquaponics stuff. But in the pond here is where we have the, that I'm going to show you. And this is what it looks like empty. It was designed to be shallow. I wanted plants to grow in this. Okay, it's only about less than 2 feet on the upper end there. And you have a winch in front of you here, and the swivel is pointed out there, and the pipe is actually about halfway down. If I needed if the swivel is a little stiff, I'll put a counterweight on that, and it helps to pull it down. And the reason I like this is this is showing capturing everything from the pond just prior to draining, and net is put on the discharge. This is the stream receiving the water from the pond. Okay, the pond is actually draining at this time, so it's coming out this pipe. And we're harvesting the fish on the outside, not on the inside. I don't chase fish around in the mud. Okay, there's a whirlpool showing the pond draining. See, there's 350 gallons a minute coming out of the spring. I can't really stop that, so we're getting all the fish out. And the darn pond's full of algae. Have you ever tried to in a pond full of algae? See these white hairs? Okay. Anyway, it doesn't work so good. So the pond gets shallower. You can see there's a couple of golden trout in this particular one. But we have a tank on the back of that truck there, and we're going to end up dipping the fish out of the water on the other side there. And so they just come through the pipe. We dip them up. We put them on the truck. And this is what it looked like when it was empty. There may have been about 2 or 3 fish. So this same type principle can follow if you have a small pond on your place and you wanted to harvest fish out of it. That's why, to me, a drain is so handy. But there are other reasons to do that too. And then I usually try to let the pond dry a little bit. In this case, I couldn't, but you can see grass started. I filled the darn thing up before the grass jumped out, and I was able to drown that grass, and my pond is still okay. So the benefits of a multiple-use pond is to enhance capacity for production of food, whether it's fish or vegetables or whatever. The ability to manage risk, contribute to food security. Ecosystem services is a word I really don't understand that well, but it's supposed to include things like this: water quality, capturing nutrients, groundwater recharge, increasing the distribution, and there's fire protection. And I would like to think that if there's enough of these and they're built well and they're intended and managed for this type of purpose, that you could impact severity of flooding. And that's all I've got. Questions?
What is microhydro?
Microhydro is just it's hydroelectric. It's a generation of electricity.
Okay.
But you're using that hydroelectric concept, but it's on a very small scale. Sir?
When watering livestock, is there a depth that you like to pull water from, A, to keep sediment out in your tank? Are you using a regulator on the pond side or float valves on the other side, or what's your favorite?
I have to confess, all of my animals have fins, and none of them are warm-blooded. The depth, the designs that NRCS have for watering livestock are very good. I would defer to their judgment on that. You don't like to have water that stinks. And for that reason, I think the deep water release can be beneficial to you in that what happens is the bad water on the bottom will become absent of oxygen, and it can get that smell. And so it's not the depth of the water you're taking it at, it's the accumulation of that particular condition there. At the same time, if you draw from the surface, you're going to have all the debris and all of the weeds and so forth, and that's not so cool. And so if I were just shooting from the hip here, I would say I'd want it, say, more than 3 feet down, but I don't want it in the section where it's bad water. That is smelly, potentially smelly water. But you should be able to get rid of that if you have deep water release.
What about spring-fed ponds?
Well, but regarding what issue?
What you're talking about, you can't use any of those things as
Spring-fed ponds simply are, to me, a source of water that is in addition to the surface water. And the idea of capturing that water and managing that water, certainly they would be somewhat different in that you never would be totally dry. But you could still, the concept of, okay, I have seen occasions where there is a nice spring and then they may be able to pond below it, and that's fine. But being interested in trout, I always like to take and put something between the spring and have like a little place where I can hold some trout or even grow some trout. Because what happens in the pond is the pond gets too warm during the summer for the trout. You know, the sun hits it, it warms up. But it's cold enough when it comes out of the ground. So if I put some kind of holding tank or some kind of container there, I can keep it cold enough for the trout year round, and I could even grow some trout fingerlings and then put the trout fingerlings in the pond and then feed them out in the pond. There's a fellow named S.D. Peters over in, he's retired now. Okay, but he's got a system where the water comes out of the it's got a nice spring, but he ends up using that water to grow trout. And then he has the ponds below it are for free fishing, and they're open on a seasonal basis. And I think it's one of the tighter little fish operations I've seen. What's going on? Sir? Well, if you're damming up a stream, you need to get a permit from the Corps of Engineers to build on it. There's something called the Clean Water Act, and that's a lot of our... What I consider a stream and what they consider a stream probably are two different things, and maybe you would consider different things as well. Gosh, I'm out of my depth here. Okay, I'm not a regulatory guy, so I'm not going to try to speak for them. But I am telling you, if you build on if you have a stream that is, I believe it doesn't even have to be a permanent stream. I believe it can be a temporary stream.
In the state of Pennsylvania, if you have a spring on your farm, and I
Okay. So, what was your original question?
there's a size.
The size. Okay.
How big of an acreage can you dam up without being permitted or
Okay.
what follows, you know?
All right. There is I believe DEP has a particular set of rules, and what is it, 25 feet?
I don't know, NRCS.
Okay.
This is not a flow, you're going to dam up an area. First of all, you get NRCS in there to look at the ground, do the core depth to see if you're going to have structure that's going to hold and maintain the pond. And then, you got to consider your aspects that below it as far as liability. And there were some of those. Once they design, once you have any problem with the core. But after that, then if it becomes a pond coming out of that or a stream, then they come into it. They say they control the water.
In Ohio, 12 foot depth of water is rule of thumb.
Okay. Pile 12 foot. I believe our DEP has a certain height of the dam is what they go by, and I think it's like 25 or something like that. Okay.
I just restored a pond last summer that is almost an acre.
Okay.
And my father built it in Chesapeake, and the plans are still in the Farm Service Bureau still has them. And that pond was engineered and built very well. It catches overflow from the natural surrounding properties all around it. And there's a couple springs that just come into it, not great springs, but they're wet weather springs. So anyhow, having said that, the natural plans, or the plans in the 50s for that pond was 15 feet. The center depth was 15 feet.
Yeah. So in answer, the regarding permits, it's more the height of the dam and the safety associated with the dam.
It's also the drainage area.
And it's also, yeah.
And the dike, of course, the dike for this particular area, the pond was dug out, and the dike was built.
Okay.
The drainage system was put through the dike was built to preserve the water, and then slow overflow area, for seepage. Now, once I got reclaimed this summer, we did have an overflow on the low place on the dike. So at least not going to a swale as go now. It was rolled out and rolled in behind the dike. So I've got a perfect little pathway. I just follow the water all there and kept, digging down a little deeper just to make enough of the trench so the water stayed, going where it needs to go. But I have a writing student's father, who's a mine engineer, he's going to come, laser it and get it all squared away for us and go ahead and just design this swale for it. But these little ponds will sneak up on them real quick when we get them back to where we first built them. But the dike, you're right in the dike. There's a lot of documentation about how high that dike was going to be built and the composite of the dike. And NRCS also has a fact sheet. Are you an NRCS guy up there?
No.
Oh, okay. But they're pretty clear cut about how those dikes have to be built to, and the compaction rates and all that. Because somewhere along the line, my dad had surfaced that with some old coal, or but then we got to worry a little bit about, we know about these things. We got to worry about how much coal actually is packed in that. It turns out that we went down deep enough to find that core, but the coal was only about that deep. So he had just run a slide hole on there to make a surface so you could ride across the bike to get to the other side of the pond, get to the pasture on the other side. But NRCS is people you want to go to, he's right.
Yeah. Well,
he's got it all down on paper.
yeah. So it's not based upon the surface area of the pond, it's based on other things.
Yeah.
And also, you can get permits to build just because a permit is required shouldn't stop you from considering it. You just have to work with the system.
You have to keep your mind out if you exceed those base things. In Pennsylvania anyway, you have to have an engineer certify every so many years, every year or 2 years, something like that. You have to have it inspected by an engineer. So it does add extra cost if you don't go those.
That's Pennsylvania.
Yeah, I'm not familiar. There's a question way in the back.
According to West Virginia DEP dam safety, the definition of a dam is 25 feet or more in height and in pound 15 or more acre feet in length.
Okay.
That is the definition of the cutoff that DEP dam safety to involve. However,
Okay. So really, once again, a visit to the NRCS office when you start is probably a good move. Sir.
You were talking about micro hydro.
Yes, sir.
I've seen one
Good.
that actually was used. And this is out in Nevada where I used to work. I worked for the Bureau of Land Management, and this old boy had built a living quarters. I won't call it a house, on public land and trespass. He ran a 4-inch pipe up this stream, and he was running a Pelton wheel. And I think he probably had propane stove or propane furnace, and he was doing it for lights,
Mhm.
maybe TV, radio. But that's the only one I've ever seen.
Okay. If you do a search online, microhydro is something that you can find out there. I'd be curious still. I think that's something the university ought to, if we put a multi-use pond on the Reedsville farm, it would give us a chance to assess some of this stuff. I think it would be cool, yeah.
Back to your swivels, if anybody needs a swivel, Akron brass, I'm in the firefighting, makes
Okay.
perfect swivel, that they use it on like the dumps of fire trucks and so forth. And they can go from 4-inch to 16-inch.
What material is it made out of?
You can either get steel, stainless steel, or plastic.
It'd be PVC?
Yeah, they make the variety.
Okay. And do you know what diameters?
It can go from 4-inch to, I think they go up to 16-inch.
Okay.
They make a variety.
Good, good. Any other comments?
Some on what kinds of fish would be good to put in a program for growing fish in West Virginia?
Okay. The most commonly grown fish in West Virginia is trout. And even in a pond, it gets too hot during the summer, trout could be grown on a seasonal basis. But normally trout are grown in association with a groundwater source, whether it's spring or if it's mine. And most of us don't have that option before us. If you do, take advantage of it, call me, I'll help you design a system, yeah.
Well, I have on my property, I have a large volume of water on the underground mine below me, and of course the biggest thing involved is the electricity and pumping that water out.
Mm-hmm.
Pump out large volumes of underground mine water and put it into some kind of like trench flow tanks or whatever.
Raceways is what we commonly use for the trout, yes.
And that, of course, it stays the same temperature year round. And
Mhm.
pump out continuous in a large volume. But considering the cost of pumping that water out to use for trout culture,
Mhm.
would that be economically feasible to do that?
Normally, it's not recommended. If you put a pencil to it, a lot will depend on your market and your cost of production. But normally, you'll find that volume of water, it's hard to make it pay. Now, there are recirculating systems that people will use, and these days, another item has come along called aquaponics, where you're combining the growth of fish with the growth of, say, lettuce or other types of vegetables. And whether that would serve as a water source for that type of system, maybe that's a better choice than trying to do the normal raceway operation like the trout growers do. One of the problems we have, something that's very different between beef cattle and fish, is marketing. You have a place to sell your animals. There is an infrastructure there for you to move your product. And where's the infrastructure for fish? You know, how many processing plants do we have in this state? Okay, how many places do we have that'll butcher? So that's a real limitation on anyone. And with the local foods interest, I'm especially interested in finding ways to market and get what I would consider more of a niche market or a moderate to high value price. Selling as a commodity is it's just foolish. You know, trying to sell, compete with Idaho with trout. So I'll give you an example of one of the things that we're doing. We have a system here west of town called Dogwood Lake, and we're growing, we have a summer crop and a winter crop. The summer crop is warm water fish, whether it's channel catfish, hybrid striped bass. Actually, we've got some Atlantic sturgeon in there that we're playing with. The yellow perch we could grow. Anyway, there's a variety of warm water fish. The cold water fish would be whatever trout, you know, brook trout, brown trout, rainbow trout. And the trout go to the recreational market in the spring. Right now, I wish I had another 1,000 pounds of brook trout because the demand for brook trout is good, and you know, we sell those for $2 to $2.50 a pound. If you buy them retail to stock your pond, you pay maybe $3 to $3.50 a pound for them. The hybrid striped bass, we're actually able to just dip them up, put them on ice, and carry them down to Madeline's restaurant. If you've eaten at Madeline's here in town, the chef there is accustomed to cutting the fish. He likes the fact that he gets them fresh directly from the producers. So this local foods market is a certain amount of opportunity. The idea of being able to just dip them up and put them on ice where you don't have to cut them. There are no health laws to worry about on that. The moment you start cutting them, you have inspections, whether it's by the health department or by Rob Nichols down at the Department of Agriculture. And just like your permitting on your ponds, it's all possible. But there is grief associated with that. There are costs associated with that. And it just makes the bar higher to jump over it. We've sold some fish at farmers markets, and I have one particular strategy that I haven't gotten clearance on right now, but being able to take a few fish over to a health-approved kitchen and having them cut them and sell them in the farmers market, I think would be a nice. So these type of pathways, you know, these type of methods of getting small quantities of fish into local markets, I think can be pretty important for the person who's just starting on a small scale. And of course, putting a cage in a pond and growing out 300 pounds of fish in a cage is something you can do for your personal use, and you know, that may have value to you as well. They were hybrid striped bass. We sell them for $5 a pound in the round. There are markets for more of those fish. Last year at the cast iron cook-off, they used our striped bass, and there were like 3 or 4 plates that won prizes, whether waterfront park or other groups, and they were well accepted.
Is that the only way you can market those fish is whole? I mean,
No, but if you,
what do you have to go through to do that?
well, you have a HACCP-approved facility. HACCP, you know, you've heard of HACCP before, I think. Hazard Analysis, Critical Control Points. Anyway, there is a routine for keeping track of records so that you have a plan and you follow it. And the livestock operations have to do the same thing, I'm sure. But you have a suitable water supply that you can be tested for, you know, to make sure that it's health. I mean, you don't want a water supply that's, you know, creates risk. So you have to send a water sample in and have it approved. You have to have surfaces, you know, being able to clean the facility up, whether it's stainless steel or some kind of, you know, the type of stuff. So these are the types of things, but you don't really have to have a big space. You know, I could have a space in the corner here, and the idea of cleaning trout in a system like that is entirely possible. It's just
The fish you produce, you're doing that too here?
Well, actually, we have at the university, we have something called a meats lab that has all of these particular things. So yes, when we cut fish, we do it in the meats lab. But more often than not, I'm selling my fish live. So they're going to the recreational market, and they might go to someone like Mike Nardella, who sells to a wide variety of folks. They might go to a fee fishing operation that can send a truck. I don't haul fish to be delivered to anybody. They have to come to me, and we sell wholesale. We do not want to be in competition with the retailers. So we're playing here in Morgantown because there is no other competition that we're impacting. And Madeline's is one of them. We've been in the farmer's market. There's a new farmer's market in Morgantown called the Monongalia County Farmer's Market that has a new format. We want to offer the fish through that. And what we do is we're really not there to make a buck. Rather, we're to gather information and to learn things and help pass that information on to folks. And I think that this new market will actually create a better opportunity for profit. We won't cut too many fish because we only cut what we have orders for. And we end up not having to spend all day sitting at a booth. Rather, we simply deliver to a drop point and they do the distribution from there. So we're hopeful on that.
Can I say something?
Yes.
I would love to buy fresh fish at a farmer's market. I'm just telling you that as a woman,
Mm-hmm.
I would like that.
Well, our customers, when we were in the farmer's market, first off, our product was fresher than anyone else around because we cut it one day, it's in the market the next day. It's a little over 24 hours after the fish are dipped that they might be being cooked. And trout was the dominant fish. And is HR in here? No, they want us to come back. They want us to come back, but I can't. I don't have the labor. I don't have the time myself to be the farmer doing that.
I'm just telling you, as a female, I would love that.
There is demand for the product.
Yeah.
There certainly is. Yeah.
So my question is about pond water testing.
Okay.
I need help with that. So who do I contact?
Okay. What are you concerned about? What do you need? I mean, if you have.
The pond that I reclaim is a recreational pond. It's not a watering pond. It's a recreational pond.
Okay, when you have a water test done, you have to tell the lab, I want it tested for blank.
Right.
So what is it you want to have it tested for?
I want to know about bacteria. I want to know, my pond needs treated right now. I mean, I need to take that step now.
Treated. Okay.
Well, for bacteria, I mean, I want to swim in this pond. This pond is like
Okay.
25 feet from my deck. I want
Okay.
to be able to go out, and I want to be able to kayak on my pond. I want to be able to
And you're using surface waters?
Beg pardon?
You're using runoff?
Yes.
Okay.
Yes, and it's clean runoff. I mean, I've been on
Okay.
the property, I'm 61, I've been on the
Yeah.
property all my life. So, it's clean, essentially it's clean, you know, as rainwater can be these days. So the only thing that's coming into it actually would be some decomposition of leaves and
Okay.
surface materials that
Yeah.
that break down in the runoff
Okay.
areas.
If you
Come into
test,
the water.
if you test for bacteria, you'll find it, but that will not eliminate the uses you've described. Yeah.
Her problems using that for a swimming pool shouldn't even be considered. Wright Laboratories will run any kind of tests on any kind of water you want to
Okay.
have run. And the whole water test was about $780 for one test.
Yeah.
Is to be good today at 10 o'clock, it's perfect. That evening you had a rain event, your pond could be highly contaminated. Recommend a swimming pool.
Okay. I think a little differently.
I can get you guys' attention. You can
Okay.
ask questions of Mr. Penn later, but we need to
Let's
stay on
talk.
track.
Excuse me.
I want to thank Mr. Penn for being here. If we give him a round of applause.
Thank you.